This is Lab 21, Example 2. We want to determine some key information about the quadratic function f of x is equal to negative 5x squared minus 30x minus 38. The first thing they want us to do is to find the vertex. This is in standard form, so I'm going to find it using the formula where the x value of the point of the vertex is x is equal to negative b over 2a. So our b is negative 30. Negative of a negative 30 is positive 30. So we have 30 divided by 2 times our a, which is negative 5. This is 30 divided by negative 10, which is negative 3. So now that we found the x value of our vertex, we need to find the y value because the vertex is a point. To find the y value, we're simply going to plug our x value into our function up here. So our f of negative 3 is equal to negative 5, negative 3 squared, minus 30 times negative 3, minus 38. And if you plug that all into a calculator, you find that that is equal to positive 7. So our vertex is the point negative 3, 7. So the other thing they want us to do is, now that we know the vertex, we can rewrite this in shifted form, or also called vertex form. This is when f of x is equal to a times x minus h squared plus k. And we can tell a lot about a quadratic function when it's in this form. We can tell a lot of vertical shifts, we can tell a lot of horizontal shifts. We can also immediately tell what the vertex is. The vertex is going to be hk. So now that we know what the vertex is, and we actually know what our a is. Our a is this first, it's our leading coefficient, which is negative 5. So we know that a is equal to negative 5, and we know that our vertex is this. We can rewrite our function up here in this shifted vertex form. So f of x is equal to negative 5 times x, and we have our h is negative 3, so it's x minus negative 3 squared, and then plus k, where k is 7. So this is the same thing as negative 5 times x plus 3 squared plus 7. So this is the shifted vertex form. We will be using this in the future. So moving on, they ask, does the parabola open up or down? And then they want us to draw a sketch. So we can tell if a parabola, if our function, if our quadratic function opens up or down by the leading consonant, or if it's in vertex form by this a here. If a is a positive number, so if a is greater than 0, then we know that our parabola opens up. And if a is less than 0, if it's negative, then it opens down. So we know that our a is negative 5. So negative 5 is a negative number, and if a is less than 0, then it opens down, so we know that our parabola opens down. So we're going to draw a little sketch of our parabola. We know the vertex. Our vertex was the point negative 3, positive 7. So we have negative 3 over here, we have positive 7 over here somewhere. Here's our vertex. We know that it opens downwards, so it's going to go down like this somehow. So this is our little quick sketch. May or may not be accurate to what it actually looks like, but this is what we can draw with the information we have so far. So using this sketch, we're going to look for the domain. Any quadratic function, you can plug in any x to it and you will find the y value. So if we have an x value here and we go down, we can touch the graph. If we have an x value here, we can go up and touch the graph. It's either direction vertically. And even over here, we can go down and it will eventually touch this graph because this keeps going outwards. So our domain is all real numbers, or negative infinity to positive infinity. You can plug in any x value into your function and you will find a y value. Our range, on the other hand, is a little bit different. Our range deals with our y values. So if we started down here and we went left or right with horizontal lines, we would touch the function. Same for over here, we touch the function either way. And we can keep doing that until we get to 7. 7 we can still touch the function. But above 7, no matter how far we go out horizontally, we can no longer actually find the function. So our range goes from negative infinity, we always go bottom to top, goes from negative infinity to 7, including 7. So that is our range. So next thing we ask is, to graph y equals f of x, how should we shift the graph of negative 5x squared? So essentially what this is saying is, if our parent graph is y is equal to negative 5x squared, then how do we get to our child graph, which is the function we actually have, which is, and I'm going to use the vertex or shifted form because it will be easier to see what transformations we use, which is y is equal to negative 5 x plus 3 squared plus 7. So if we started out with this parent graph, how could we move this parent graph to get this child graph, which is our actual function? So first thing we're going to notice that instead of x, we have x plus 3 squared. So if something is with our x, that we're going to be dealing with a horizontal movement, and here we're adding 3. And with horizontal shifts, it's always the opposite of the sign. So if we add 3 to our x, that actually means we're going to the left 3 spaces in our graph. So we are shifting left 3 because of this positive 3 here with our x. And we are adding 7. So after this shift, we are actually adding 7 to our parent graph. If we add 7, that means we are going in the vertical direction. If we add a positive number that's positive, then we're going up in our graph. And if we subtract a number, then we're going down in our graph. We're moving our graph down vertically. So because we're adding 7, we are also moving our parent graph up 7. So this is how we would shift the graph of negative 5x squared to get our function that we actually have. So the last thing they're going to ask us, well, one of the last things they're going to ask us, is where is f of x increasing or decreasing? So this has to do with our little picture here, and has to do with the slope. So here in our graph, we can see that if we're going from left to right, we actually see that we're increasing. Our slope is increasing up until when we get x is negative 3. And our slope is decreasing after x is negative 3. So we are increasing when x is less than 3, negative 3, and we are decreasing when x is greater than negative 3. Another way to say this is when we have, in interval notation that is, from negative infinity to negative 3 we are increasing, and we are decreasing from negative 3 to infinity. Generally speaking, we put it in interval notation. So last thing we want to do is we want to find the intercepts. So first I'm going to find the y-intercept. The y-intercept is when x is equal to 0. So in our original function, let me grab that real quick. In our original function, we're going to substitute 0 in for each x here. So we have f of 0 is equal to negative 5, 0 squared, minus 30 times 0, minus 38. And this term will be 0, this term will be 0. We're left with just negative 38. So we know that our y-intercept is the point 0, negative 38. So let's say equals negative 38. So that's our y-intercept. We need to find our x-intercepts. So we have our x-intercepts are when y is equal to 0. And we have our function here. So we're going to set our f of x as 0 and then equal to this. So we have 0 is equal to negative 5x squared minus 30x minus 38. And at this point, normally you would factor this, but this looks kind of hard to factor, so I'm going to use the quadratic formula. So the quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4 times a times c divided by 2a. So we're just going to get straight into plugging in our values. Negative b is going to be, b is negative 30, so a negative of a negative is going to be positive 30. This is positive 30 plus minus square root of negative 30 squared minus 4 times a, which is negative 5, times c, which is negative 38, divided by 2 times a, which is negative 5. So now we just need to simplify this over here real quick. So if you plug everything that's inside this square root into a calculator, you get 30 plus minus the square root of 140 divided by 2 times negative 5, which is negative 10. And we can further simplify 140. 140 is divisible by 4. And then if we take 4 is the same thing as 2 squared, so we can take 2 out of this square root, and we're left with 2 times the square root of 35. So this is 30 plus minus 2 times the square root of 35 divided by negative 10. And we can factor out 2 from the numerator and the denominator. So this is 2 times 15 plus minus 1 times the square root of 35 divided by 2 times negative 5. And 2 over 2 is just 1. So this simplifies to x is equal to 15 plus minus the square root of 35 divided by negative 5. And we have 2 x-intercepts plus minus, which would make sense in our picture where we touch the x-axis twice.